Hello guys, it's Dr. AJ. Today we're going to solve examples on phase relations. It's one of the important topics in the geotechnic, and you're going to get all the time questions in the FE and the PE exam about them. So I made 3 examples really quick and simple, so I hope you can get something out of it. First example, we have a soil sample, a saturated clay. We have the wet mass or total mass is 712. The dry mass is given as well, 489. And then we have the total volume, 6.22 cubic feet. And they're looking for the specific gravity of the sample. So when I start solving equation, the first thing I do, I just write down what is given. So the total weight is given, or the wet, sometimes called the total, sometimes it's the wet. So the weight of solids is given as well, and the total volume. We move ahead. What we're looking for is the specific gravity. What's the equation? It looks like this, and in the manual it looks like this. So this is basically how it looks like, and it's very important to remember how it looks like, or at least just get familiar with it, so that when you flip through the pages or when you search online through the PDF in the exam, you're familiar with the equation and how it looks like. So the equation basically is the weight of solids, and it's given. The volume of solids, we don't have it, and the gamma water. Gamma water is given. If you go to the reference manual, it's 62.4, and that's how it looks like. And there is a gamma saturation equation right on top of it. So if we go back, the weight of solids 489 is given, gamma water is given. We need, in order to find the specific gravity, we need to find the volume of solids. But we have the total weight and the total volume. So we start with the total weight. Total weight basically is the weight of solids and the weight of water. The weight of solids is given, the total weight is given, so we can get out of this the weight of water. 712 minus 489, we're going to get 223 pounds. This is the weight of water. And since gamma water is weight over volume, and gamma is given, the weight of water, we just found it. So the volume of water, it can be found out of this. And we're going to get 3.57 cubic feet. So, and then now we have the volume of water. We have the total volume. We can find the volume of solids, which is 2.65. Now, basically everything in the equation is known. The weight of solids is 489. The volume of solids is, we just found it, 2.65, and gamma water is already given. So we just plug in the number, we're gonna get 2.96. We go back to the option, is the closest thing is 3. So it is, the answer is basically D. Simple, common in the PE and the FE exam. Quite positive. If you're gonna get any, very positive in the FE exam, you're gonna get probably something shorter. You don't have to apply that many equations, but for the PE exam, definitely this is a PE question, like as a whole. The second example, we have a soil sample. Specific gravity is given in this one. The void ratio, E, is given as well. The water content, the W, 11% is given, and we're looking for the degree of saturation. There is a specific, there is a direct equation to solve that. This degree of saturation is basically the water content times the specific gravity over the void ratio. And that's how it looks like in the manual, in the reference manual. This is the degree of saturation. We've got the water content, 11. We're going to be using the second equation because that's what we have here. The water content is 11, specific gravity is given 2.8, and void ratio is 0.7. One important aspect really, 11, when you use this equation, when we put 11%, you're going to use the number 11. You're not going to put 0.11. It's not 11 over 100. You're not going to deal with it as a percentage as much as you're going to take it as a whole. When I say 11%, you use the number 11. So this is very important. That's why I practice and try to solve as many examples is really crucial in the FE and the PE exam. The more you solve, the more the easier it's going to become. So with that, you're going to get 44%, and it's basically C. Example 3. So we got a soil sample, a void volume 1.6 given, solid volume given as well, specific gravity is given. What we're looking for, what is most nearly, this is very important, you're not looking for the exact number, most nearly. Void ratio, number 1, saturated unit weight, number 2, and submerged, sometimes called effective unit weight, so please pay attention. Okay, we start the solution. First, what we're looking for, the void ratio, and that's the equation and how it looks like in your manual. I took snapshots for the equation from the manual and put them here in the presentation so that you will become familiar with it, and at the same time when you go back and try to solve it, oh, you remember, like, oh, we solved it before, so that's how it looks like. That's the reason I tried to do it both. First is my handwriting, and the second one, which is the most important, the equation from the reference manual. I want you to get familiar with it so that when you go and flip through the pages or you search it, once you see it, it's like, oh, okay, I've seen it before, it's this one. That's why. So we go back to the example. Void ratio, that's number 1, what we're looking for. Number 2, saturated unit weight, and we have this equation, and then gamma water is given, which is called effective or submerged unit weight, which is this equation. So those E, gamma saturation, and gamma effective, what we're looking for. Okay, so we go back and write down what's available. Volume is solid is given, volume of voids is given, and specific gravity is given. So first we find E, the void ratio. Volume of void and volume of solid, both given, 1.6, 2.45, 0.65. Boom, done. The second one, gamma saturation, is this is equation. GS is given 2.6, right? E, we just found it, 0.65. Gamma water, 62.4, and it's this from the manual. Please pay attention to the unit. Since everything here in cubic feet use US units, or British units sometimes called, we're gonna be, so pay attention, because there's a chance they're gonna give it to you in kilonewton, the SI units. So that's why we use 62.4, because everything in the US units. And then 1 plus E, 1 plus 0.65, and that's going to give us almost 1.23 pound per cubic feet. So we're done with the gamma saturated. Now we're going to go to the final thing, which is the gamma effective. Gamma saturated, we just found it 123 minus gamma water, 62.4, and that's going to give us 61 pound per cubic feet. So that's going to give us an option A. With that, thank you very much and see you next time.